Formnext 2023, and I'm at the Nexa booth. This is my friend John. Hey, John.
Hey, pleasure to see you again.
It looks like there's metallic parts here,
Yep.
and we're talking about the QLS system,
Sure.
right? QLS, what exactly is that?
So QLS is the Nexa brand of selective laser sintering machines. They are open platform machines. That means that our customers can buy material from us or they can source it from someone else. Our philosophy with selective laser sintering is to allow the customers to be in control of the type of parts they want to produce. And we think philosophically, that's where the market has to go.
And here at Formnext, anytime someone from a company mentions the word open, it just fills my heart with joy.
Right.
Now, talking about materials,
Yep.
being able to bring their own or use Nexa branded materials, because I'm sure you sell some wonderful
We
materials
do.
for this
We
QLS
do.
system. It looks like this machine can do vastly different parts because these are squishy,
Absolutely.
foldable parts, and this, I mean, that's metal, right?
Yeah, exactly.
From the same machine. So talk to me about that.
Yeah, so the nice thing about our machines is we want to promote versatility and capability. We want our customers to be able to, in one day, make a change from soft elastomeric parts for soft touch, human interface type materials, all the way to titanium and stainless steel materials for production metal grade parts.
Production, like this is a
Absolutely.
part.
We actually, in fact, use that part on the handle of our QLS
Oh, is that
machine.
it? Wait,
That's it.
wait.
Yeah, that's it.
What? You know, a lot of times coming from the consumer world of, rep wrap and additive,
Yeah.
a lot of times there are machines that are 3D printing
Yeah.
their own parts.
Exactly.
The machine could do both of these things in a
Absolutely.
day.
In a day.
In a day. So
That's
someone
right.
could print an elastomeric
A
material
soft elastomeric.
and then switch over to a metallic material in the same day. So let's talk about this material
Yeah.
first. I would imagine these are Nexa materials here.
Yeah, this is a material called TPC.
Okay, so we've got TPU,
Yep.
we've got TPE,
Yep.
now we have TPC.
Yep.
Okay, what is the C?
So the C is a copolymer material that adds polyester. So the nice thing about this material is the durability.
Oh,
You're
yeah.
adding an industrial grade durability to an elastomer, so you can do real production parts with soft touch material in the SLS format, which is going to give you the lowest cost per unit.
May I see that?
You can.
So this is direct from the machine,
Direct
this
from the
midsole.
machine, from the midsole.
Obviously, this is a fabricy piece, and
Yep.
this is the bottom part. This is
Absolutely.
treads so you don't slip, but this part right here, straight from the machine.
Straight from the machine. We can dye it, we can vapor smooth it, you can add your own artistic touches, but it's a industrial production grade material.
The QLS system, they're pulling parts from the machine and
Absolutely.
integrating them into other materials, and then this is something someone's
For
buying
production.
in a retail
Absolutely.
environment. Oh, wow.
Not just in footwear, but in orthotics and prosthesis, where you want that soft touch, you want materials that are going to interface with humans.
And this is the TPC.
This is TPC.
So this is that polyester element is really adding
Yeah.
to the longevity of the part.
And durability, it also adds to the capability. So we're able to do very thin walls, but still have production grade capability and durability at thin walls, where in this case, this is a pediatric ankle brace.
Yeah, it's super
And so
tiny.
you really want it to be very thin because this needs to go in the shoe. And if we have a material that's not as strong, we have to double, triple, or even make the wall even thicker for durability. With this, we get all the durability in a wall thickness that's under 1 millimeter.
So something like this printed in a material that we might know of, like the TPU or the
TPE.
TPEs, it's going to be a little bit thicker for the durability,
Definitely.
and it's not going to have that memory of its shape.
That's exactly right. It's
So
not
that-
going to be durable. It's going to be more bulky. In the real world, it's not as good of an appliance as it would be if we're able to thin out the geometry and make that human interface on a soft touch material better.
What I love about additive is the advent of these newer materials.
Yeah.
We're
This is
talking
the-
about the future, man.
Yeah, this is the beauty of open materials, is that materials are going to continue to innovate, and being able to bring new materials to your machine that you already have, it renews the capability of what's possible with your machine.
Well, so I'm working now. I'm a worker, and my QLS system just produced a bunch of these for a
Yes.
local children's hospital.
You bet.
And it's now noon. I'm about to have lunch, but I want to print some metal
Absolutely.
next, and it's not going to take long to switch over.
No, you can do it in 45 minutes to an hour. You can switch over completely from any of our materials to the metal technology.
Well, now when we're talking about metals, I know that powdered metals, there is a safety concern.
Sure.
How is that handled when we have two different materials in the same machine?
Yeah. So the nice thing about our cold metal fusion technology is it is a metal, but it is coated with a polymer. So you don't have any of the safety concerns around using pure powdered metal. You don't have the flammability and reactivity that you may have with powdered titanium if you're doing DMLS. So it's a double benefit.
That's
the
cool.
materials are easy to handle, they're safe, and yet they yield parts that have better than billet machining mechanical properties.
But they're coated.
Yep.
How does that happen?
Well, the coating is just really the vehicle to create the part. We center the coating, not the metal, in the SLS machine. Once we end up centering the polymer, we put the part into a debinding system, which removes 98% of that polymer.
Oh, so there is a debinding
There
process.
is a debinding process, and then it goes into a center furnace. So at the end, we actually have more pure metal feedstock than if you buy a piece of round bar and start to machine it. So we end up with better mechanical properties than billet machining, which is amazing.
When we talk about additive and the benefits that it offers, obviously it's not the tool that solves all.
Yep.
And we have to think about how it's able to adapt itself to more traditional techniques. And the way we do it is either in the customization, the cost, or in the performance. So then if we're able to create parts stronger than a milled part, how is the cost?
The cost is extremely competitive with billet machining, because obviously with billet machining you're going to have a lot of waste. This has zero waste. The beauty of this material is it's called cold metal fusion. We center it at very low temperature, so all of that powder that surrounds the part is 100% reuse. So a company like this Utilis tool holder, this is a full production part. It's a tool holder which has conformal cooling channels built in. These are in 100% production through this process using our QLS machines. So you can buy these tools from your local tool supplier. Every single one gets manufactured on the Nexa QLS platform.
Wow. Obviously, it doesn't come out with all the nice lettering and the QR code.
That's right.
But you're left with a part similar to how you would mill it out of feedstock.
That's right.
And so the same processes that apply to that then apply to this for finishing and making it a proper retail sort of part.
And the big advantage is we can do internal coolant channels like this part has that you could never machine.
No, never.
There you go.
John, this is impressive. I love being able to talk about this.
Great.
But we have one more thing.
Sure.
One more thing. And I was holding it at the beginning. John, this is a basketball.
It is.
What is the build size of these QLS systems? Because this is a large part.
It is large. It will actually fit on either machine. The smaller machine is a 230 by 230 by 250. The large QLS 4-laser machine, which is the fastest SLS technology in the market, is 350 by 350 by 400.
You just dropped, it's the fastest on the market?
Yeah, the 4 lasers gives you unbeatable process time and scan time per layer. So it is the fastest powder-based technology in the market.
Can you tell me then, on that big machine, what was the print time on this basketball?
Yeah, we can print those basketballs in about 5.5 hours.
You know, on the consumer side, we're talking about the advent of speed on the FFF side.
Sure.
You know, we've got some machines that are really kicking it into high gear, and it's great to know that the industrial process isn't far behind.
Absolutely.
You guys are speed freaks too.
Speed is important to everyone, to getting the price for additive manufacturing down, not just from a per part cost, but a time cost is also crucial.
John, this has been amazing. I'm really thankful that you told me about this. I know Formnext this year has kind of an overarching sustainability theme.
Absolutely.
And being able to use the material 100% recyclable.
Yeah.
I've got one more thing. So the audience is right there. Look into that camera and let them know where they can go to find out more information.
You can find out everything you need to know about fast XLS printing with elastomers and metals at Nexa3D.com.
So if you made this fire awesome, don't forget to hug each other more, fight for a cause you believe in, print all the things really fast, and as always, high five. There we go.
Great.
Nailed it.
Awesome.